Alright, so you've already learned how to sketch quadratics from turning point form. This time we're going to sketch quadratics from the general form. And you should remember that the general form is y equals ax squared plus bx plus c, where a, b, and c are just numbers of some kind. So we've got an example here, y equals x squared plus 2x minus 15. A is 1, b is positive 2, and c is negative 15. Now, how are we going to sketch this? Now, we could complete the square. We could turn it into turning point form and then sketch from turning point form. But there is a way to avoid that completing the square, avoid turning it into turning point form, and still be able to sketch it. So, to sketch a quadratic, you really need three things. You need a y-intercept. You need to know the turning point. And you also need to know the x-intercepts, with a caveat here, if they exist. So obviously if the x-intercepts don't exist, we can't find them. But as long as we know the y-intercept, as long as we know the turning point, and as long as we know the x-intercepts, we can sketch this thing. So, first of all, let's find the y-intercept. And to find the y-intercept of anything at all, it's always let x equal 0. So in this example, y equals, let's get rid of that, 0 squared plus 2 times 0 minus 15. 0 squared is 0, 2 times 0 is 0. Finally, the y-intercept is negative 15. Alright, now if you think about that, we can almost avoid all of that action, because anytime we let x equal 0 in a quadratic, it'll be 0 squared times some number, which is going to be 0, and then some number times 0. So these are always going to cancel out. So in the general form, the c value is always the y-intercept. So we can avoid the calculation and we can just say the y-intercept is equal to negative 15. Boom. Okay. Now we need to find that's sort of step 1, I suppose. Now, we need to find the turning point, but I'm going to do that in 2 stages. First, I'm going to find the axis of symmetry. The parabola is symmetrical, and then I'm going to find the turning point. So, axis of symmetry. To find the axis of symmetry, we can use a formula, and that formula is negative b over 2a. Negative b over 2a. So in this one, it's negative 2 over 2 times a, which is 1. Alright, so the axis of symmetry here is negative 2 over 2. The axis of symmetry is negative 1. So think about what that means. I'll just draw my tiny little quadratic over here. There's an axis of symmetry here at negative 1. Okay, that's going to be my quadratic. Now, I know my axis of symmetry, which is my x value of the turning point. I know that the value of the turning point is going to be negative 1 something. So I can sub in negative 1 for x into our equation. Okay, because if I sub negative 1 for x into our equation, I'll find out what y is, and that's where the turning point is. So y equals, different colour maybe, y equals negative 1 squared. Always do the brackets like this, otherwise you might end up in trouble. Plus 2 times negative 1 minus 15. Negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 minus 2 minus 15. So that's 1 minus 2 is minus 1. Minus 15 is minus 16. So we can say that our turning point is equal to the axis of symmetry, negative 1, and then this y value, negative 16. Alright, so I know two things about my quadratic so far. The y-intercept is negative 15, and the turning point is negative 1, negative 16, just below that. Finally, I need to find my x-intercepts. These are sometimes called roots, sometimes called zeros. To find an x-intercept, it's always the same deal. Let y equal 0. So, in this one, that means that 0 equals x squared plus 2x minus 15. Now, we need to solve that. We need to find out what our x values are. And there are two ways you can do it. If this factorizes neatly, you can use the decomposition, AC method, splitsies, whatever you want to call that. If it factorizes, factorize it. But if you're not sure if it's going to factorize, the best way to do it is to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That'll give us our two roots. So that means that negative b, so negative 2, put it in brackets, plus or minus the square root of 2 squared minus 4, 1, negative 15, all over 2 times 1. So that's going to be negative 2 plus or minus the square root of, that's 4, minus, so this is where things get tricky. So it's minus 4 times 1, which is minus 4, times minus 15. Minus 4 times minus 15 is plus 60, all over 2 times 1, which is 2. This is going to come out neatly because negative 2 plus or minus the square root of 64 is 8. So it's going to be negative 2 plus or minus 8 over 2. And then we can just do our two answers. Negative 2 plus 8 is 6, divided by 2 is 3. And negative 2 minus 8 is negative 10 over 2, or negative 5. Alright, so we've got our two answers here, 3 or negative 5. Yep, that looks right. Finally, we need to sketch this, so I'm just going to hide over here for a second. Now, the y-intercept is going to be negative 15. The turning point is going to be negative 1, negative 1, negative 16. Okay, and the roots are going to be 3. That's 1, 2, 3. And negative 5. 1, 2, 3, 4, 5. This is getting to be a bit of a disaster. So it's going, here's my axis of symmetry. It's going to pass through 1, 2, 3, 4, negative 5. It's going to pass through positive 3. It's going to be a quadratic that starts up here, comes down to the turning point, passes through here, back up. Alright, not my finest work, but there's a sketch of our quadratic, y-intercept, turning point, and the two roots. Sketching quadratics from the general form.